Hi folks. Today we're going to continue looking at different forms of quadratic functions or parabolas. So the next most common form that we're going to run into is this vertex form, and we ran into it when we did our investigation. And you notice that it's got a bracket squared and then an extra number at the end. That means that it's not in fully factored form. Instead, it tells us where the vertex is, hence the name. So you've got a coefficient out front. This is actually called the leading coefficient. And if it's positive, just like with factored form, the parabola opens up. If you have a negative a value, it opens down. And larger a values in terms of magnitude, so like a bigger number, either 1,000,000 or negative 1,000,000, will make it steeper. Now, what vertex form tells us, not surprisingly, is where the vertex is. So the vertex is going to be at the point hk. Okay? So h is the number that you subtract from x in this little squared binomial, and k is the number that's tacked on to the end. For x-intercepts, this one's a little trickier to find the x-intercepts, but we just sub 0 for y and solve. But not all parabolas have x-intercepts, so it may not exist, but they may not exist. Let's think about what that looks sort of geometrically. If you had a parabola that looks like this, of course it opens up, but it doesn't have x-intercepts, so it's not a guarantee that we'll end up with x-intercepts. Okay, let's do a little graphing here. I guess one other thing before we go there we could say is that the axis of symmetry is going to be on the x-coordinate of the vertex. So let's write that in. Axis of symmetry. Okay, that'll be at the x-coordinate at x equals h. So this number right here. Let's put that to use in actually graphing a couple of them. So I've got x minus 2 all squared plus 5. Let's see what we know here. We know that this is positive to start with, so it opens up. And it's going to have a vertex at 2, because we have x minus 2 here. It says the form's x minus h all squared, and 5. That's pretty good. We also know that the axis of symmetry is going to be right on x equals 2, because if you have any parabola, the axis of symmetry is going to be right at the x-coordinate of the vertex. Lastly, it asks us to find the y-intercept, and we've already talked about this. To find the y-intercept of any function, all you do is you sub in 0 for x. Sub 0 for x. And you're going to have to do it carefully. So here was the function, x minus 2 all squared plus 5. Let's go ahead and put in 0. 0 minus 2 all squared plus 5. And that would be negative 2 squared plus 5. Or 4 plus 5 is 9. There's our y-intercept. At this point, I think I'm ready to try to graph this thing. So I'll just plot the points that I know. I've got a vertex at 2, 5. 1, 2, 1, 2, 3, 4, 5. There we go. 2, 5 for the vertex. I've got a y-intercept at 9. So 6, 7, 8, 9, somewhere up here. I can graph the axis of symmetry. First, let me just graph what I've got so far. What I know that I have is the left-hand side of the parabola. And this is the point 0, 9. Let's draw that axis of symmetry in now. Okay, it's at x equals 2. And I know that this graph is going to be symmetrical about that axis of symmetry. So I could just kind of eyeball it. It looks like this. I can also reason out that the point 4, 9 is going to be on this graph, because 2 to the left of the vertex, we had 0, 9, or a y value of 9. So 2 to the right of the vertex, since it's symmetrical, is going to have that same point, okay, or that same y value. And that's a good graph, and it probably took less time than it did for the factored version. This one couldn't be written in factored form, and that's because it doesn't have any x-intercepts. We'll take a look at 2 more. So let's describe what's going on with this one. It's got negative leading numbers, so it opens down. You could also mention that it's going to be kind of steep. And then we've got to figure out where the vertex is. Now remember, what we were given was some form like this, ax minus h all squared plus k. This, unfortunately, has a plus. But a plus just means x minus negative 1 all squared plus 2. And a negative 3 up front. So the vertex is going to be at negative 1, 2. Some people like to just make a rule that it's the negative of this number, or the flip of this number. I guess not the upside down flip, but the opposite sign. And then it's just this for your y, the number that's tacked on the end. Once we have that, we know that the axis of symmetry is at x equals negative 1, because it's always just at the x value of the vertex. And we can find the y-intercept fairly easily. Y-intercept sub 0 for x. Okay, and we'll, again, do it carefully. So that would be negative 3, 0 plus 1 all squared, plus 2. Careful about order of operations here. So that's 1 squared plus 2. 1 squared is just 1 plus 2. So we have a y-intercept at negative 3 plus 2, or negative 1. Now we're ready to make a graph. Let's plot the points that we know. So the vertex is at negative 1, 2. And we've got a y-intercept at negative 1. So now that I have 2 points, and I guess I could label them, this is the vertex at negative 1, 2, and I've got a y-intercept at 0, negative 1. I could go ahead and draw in the axis of symmetry. So there it is. That just lets me know that my whole parabola is going to be symmetrical about that vertical line. All right, well, let's try and turn this into a parabola. There we go. Now again, I can use the idea of symmetry to reason out that there's going to be another point with a y value of negative 1 unit to the left of the axis of symmetry. So at negative 2, negative 1, there'll be this other point. How many points are on this parabola? Infinitely many. But showing 3 is definitely enough. In this case, it only asks us to show the vertex and the y-intercept, but you want to make sure that there's at least some symmetry in the way that you're sort of sketching it out. For this last one, we have a fractional leading coefficient, but that doesn't actually make things any more difficult. We know that this opens downward. And we can reason out where the vertex is. So just to do this quickly, it's going to be the negative of whatever number is here, or switch the sign, and then the y value will just be this number over here. So vertex at negative 2, negative 1, it opens down. We can say that the axis of symmetry is always just at the x value of the vertex, so x equals negative 2. And we can find that y-intercept by subbing 0 for x. So that's going to be y equals negative 1/3, 0 plus 2 all squared, minus 1. Let's work this through. So that's negative 1/3 by 2 squared minus 1, or negative 1/3 times 4 minus 1, negative 4/3 minus 1. And again, we can do this. This is just going to be 3/3. That's how I think of that 1. So I ended up with y equals negative 7/3. Or negative 2 1/3. Now somebody's going to want to call that negative 2.3. That's not quite right, hey? A third is a fraction that continues forever, so we're better off staying in fractional form. Let me make some axes here. I'll just use, well, maybe I'll draw it in again. And I can simply plot what I know. I've got negative 2, negative 1 as a vertex. Okay. V, negative 2, negative 1. I have a y-intercept of negative 2 and 1/3. And I'll probably label it because it is not on an integer, right? It's not a negative whole number. And I know my axis of symmetry, so maybe I'll draw that in just so it's clear where we're going to have our symmetry about. So we have x equals negative 2. And then finally, I'll just make my parabola. So that gives me this point here. Okay. And on the other side, it'll just look the exact same. And notice that y-intercept was 2 to the right of the axis of symmetry, so I'm going to have a similar point 2 to the left of it, which would be right here at negative 4, negative 7/3. So in this question, all we're doing is graphing the function. You notice that if we compare b and c, b is really steep, okay? And that's because it had a leading coefficient that was big. It had a negative 3. C is wider because it has a leading coefficient of negative 1/3. In terms of practice, you can head to the old textbook, page 33, numbers 4 and 5. Let me know if you have questions, folks. Take care.